c squared equals 13. Take the square root. What happens when I take the square root? Plus or minus 13. So now are both of them the answer?
Square root.
Just kidding. Square root of 13. Which of those two would be a valid answer? Or are both of them?
Just square root of 13.
Just the positive one?
Yeah, because you have an interval.
We have an interval, right, that we're looking for that c value to be in, between 2 and 5, right? Okay, so must be in the closed interval 2 to 5. Understand? You're imagining an x value in between those two that when you go up, splits up the space, right? And you create this rectangle that will have the same amount of space as the curve had. It leaves the unbounded and the bounded above and below equal. Cool? Seems easy? You think you'll remember that average value formula? Alright, so let's do it. Find the average value of this function from 1 to 3. Calculator, yay! So let's do it. What do I set up? Okay, what's it gonna be? 1 over 3 minus 1, which is 2, times the integral of, from 1 to 3, of x to the third times the square root of sine squared x. So do we save ourselves some time? What is the square root of sine squared? Just sine, right? So when I type it in my calculator, I could probably save some time and avoid having to put that square root, avoid having to put that sine squared, by just putting x to the third times sine of x. Oh, how cool. Okay? And tell me what you get. And don't wait for other people to type it in. You type it in. Get your calculator and practice. You'd be surprised how many people get these wrong because they don't know how to type it in. Because they waited around all year for somebody else to type it in and get the answer. And then they realize that they didn't know how to type it in to begin with. They thought it would be something so simple. This is, we're only doing one problem, so I don't want to do this one on the graph, right? We're just doing one problem. If it was a problem with several parts where we're going to have to use the equation several times, then yes, I'd put it on the graph and store it there, right? But that isn't the case here. What do we end up with, guys?
5.84.
5.848? Awesome.
Can I borrow the keys?
Yes, for the lab? Oh man, okay. The man, you know? Alright, let's try another one. What does this one say?
Edit that out.
Non-calculator? Find the average value, let's do it. What's my formula? 1 over 6 minus 2, which is 4, of the integral from 2 to 6, it's not 3, of 2 minus 4x dx. We always want to include the setup, whether it's calculator or non-calculator. Okay, you have to put the setup, or else they won't give you credit. You'll lose a point. If you just put the answer, like on this one, if I just put 5.848, I'd probably lose a point because I didn't provide the setup. Okay, want to make sure you get all the points for that question. All right, so we've got to do this one by hand. So 1 over this is not 1/3, but 1 what? 4th times the antiderivative. So what's the antiderivative of this guy? 2x minus 2x squared,
Yeah.
evaluated from 2 to 6. Is everybody okay on how I got that antiderivative? Remember, we add 1 to the power and divide by the new power. So far, so good? Right. So let's actually evaluate this. So we're going to get 1 over 4 times, put in the 6. 6 times 2? 12 minus 6 squared? 36 times 2. $72. Minus, now plug in the bottom limit. Put in 2. 2 times 2? 4. Minus 2 squared times 2? Alright. So what's 12 minus 72? Negative 60. And then this becomes negative 4, but it becomes plus 4, right? Because you got minus that negative. And negative 60 plus 4. Negative 56 divided by 4 because of this guy over here.
Negative 14.
Negative 14? What? How many 4s into 5? 1. 5 minus 4, that's 1. Break down to 6. How many 4 into 16? 4. Woo! Correcto mundo. Good? Alright, did they ask for you to find the C value? No, but let's find it anyways, just for fun. Find C. How would I find the C? We know that this is f of C, right? The average value. So we would say what? F of C is equal to 2 minus 4C, which we know is equal to negative 14. Minus the 2. Divide by negative 4. Is 4 on the interval 2 to 6?
Yes.
Yes. Got it? Super easy? Try another one. With some tricks. Non-calculator, oh my god. What, the unit circle? I have to know that? So let's see. Ale, will you read this one to us?
Find the value of C guaranteed by the mean value theorem for integrals for the function f of x equals cosine of x over the interval.
Negative pi over 3 to positive pi over 3, right? So what do they want me to do here? Find the C value, right? Am I going to freak out because it's not written the same way as all the other ones were? No, basically they want you to find the C, right? In order to find the C, I first need to find the
Average value.
average value, right? So that's kind of what this means, right? The word mean. Yeah? So the average value theorem for integrals. Okay, so let's do it. Let's first figure out that average value. So we can know that f of C, and then we can work it from there. So that formula says what? 1 over b minus a, so pi thirds, right? Minus negative pi thirds. Times the integral from negative pi thirds to pi thirds of cosine of x dx. So what's pi thirds plus pi thirds? 2 pi thirds, but 1 over 2 pi thirds is the same as
3 over
3 over 2 pi, right? And we're going to multiply that by the antiderivative of cosine, which is sine evaluated from negative pi thirds to pi thirds. So what's sine at pi over 3? Radical 3 over 2, so we have 3 over 2 pi, right? Times radical 3 over 2. Minus, what's sine at negative pi over 3? Still radical 3 over 2, but now the sign changes. So what is the sign? Where is negative pi over 3? What quadrant?
4.
Quadrant 4. What's positive in quadrant 4?
Cosine.
Only cosine, right? So, that means sine has to be negative, right?
Yeah.
So negative radical 3 over 2. That becomes plus radical 3 over 2. So 1 cookie plus 1 cookie equals 2 cookies. So what do we end up with here? 3 over 2 pi times
2 radical 3 over
2 radical 3 over 2,
which is radical
which is just radical 3, which is just 3 radical 3 over 2 pi. Now that's not the c value, that's the f of c. Bless you. So ultimately, how would I find the c value?
3. You would equal cosine.
F of c is equal to cosine of c, right? Which is equal to 3 radical 3 over 2 pi. And how would I solve for c?
You do inverse.
The inverse? Okay. So we would say c is equal to cosine inverse of 3 radical 3 over 2 pi. Such that c is in the closed interval what?
Negative radical.
Negative pi
Pi radical.
thirds
Pi over 2.
to pi over.
So pi over 2.
And we want to say that at the bottom, right? Because there might be a lot of answers that give us that. We only want the c that is in that interval. We're not actually going to calculate it because we don't have the calculator. It'll be kind of hard to do. Okay? So we'll leave it like that. You understand? That would be deemed acceptable. So far so good? We're still awake? One more problem, okay? This last problem has 5 parts. So let's see if we can get through all 5 parts before the bell rings. Okay? Now we're going to give you a real world problem. Ready? Like they do on the AP test.
Readers or what?
You don't like these real world problems? It's beautiful. You get to see calculus in action.
Oh, like they already did.
Sir.
Alright, so it says here.
Oh yeah, I saw that.
A ski resort uses a snow machine to control the snow level on the ski slope, okay? Over a 24-hour period, the volume of the snow added to the slope per hour is modeled by this equation. So what does this equation represent? The volume of the snow added per hour. Oh, so is this a rate or is this an amount? It's a rate. It's how much snow is added per hour. Okay, good. The rate at which the snow melts is modeled by this function. So what does this function tell us? The rate at which the snow melts. Both S of t and M of t have units of cubic yards per hour, and t is measured in hours from 0 to 24. At time t equals 0, the slope holds 50 cubic yards of snow. So how much is there when they start? 50. Is snow being added? Is snow going away? Yes, because it's being melted, right? Alright, cool. Compute the total volume of snow added to the mountain over the first 6-hour period. This is calculator active. So how would I do that? How do I figure out how much snow was added in the first 6-hour period?
The integral
The integral
of 0 to 6.
from 0 to 6 of S of t dt. Oh, okay. So the volume of the snow added is equal to that. Okay, specifically from 0 to 6, right? So on this problem, since we're going to have several parts on it, I would recommend that you go to your graph and you type in the 2 functions, one of them in like F1 and the other one in F2. Okay, remember, if you want them to be F1 and F2, just create a new document by pressing Control-N, and that'll delete all your documents that you have open previously, and you start from scratch with a brand new one. Okay? And I would type in the 2 equations there, so that way every time you want to use an integral of them, you don't have to type in the whole equation, you can just use the vars and refer to that particular function. Just remember which one's which. So on your paper you could put like F1 and F2, or if you can remember in your head, well that's even better.
Yeah.
Sign of that, and the whole thing's squared, right? Okay?
That would be,
Yes, the squared, you'll put parentheses here. So you can put x times parentheses around all that, and then the squared of it. Remember when you do this, right, sometimes if you type this, like if it didn't have squared, you would have to put a times between that variable and that sign.
But if you didn't need it,
It picks it up as like text or something. Okay? Doesn't automatically assume that it's multiplied. Good? So what do we get for this one? Doesn't let you do it? What did you type in under f of x? There's another parentheses, x over 14, so you gotta close the parentheses again, then put squared.